Today we are going to implement off adder and full adder using the Electric Circuit Studio app. This is the interface of the Electric Circuit Studio app. In the bottom row, the components are present. In the top row, some of basic properties of the components are present. We will see the circuit diagram of off adder. Off adder is a circuit which just adds 2 bits and produces 2 outputs, sum and carry. The truth table for off adder is here. When both are 0, 0 plus 0, it gives sum 0 and carry 0. 0 plus 1 means 1, 1 plus 0 means 1, 1 plus 1 means 10, 1, 0. So it propagates the 1 to the carry and gives produces sum as 0. The circuit for off adder is just an XOR gate and an AND gate. Both inputs A and B are connected to both the gates. Generally in the laboratory, we are implementing the digital experiments using the digital IC trainer kit. In the bottom line, the inputs to the gates are present. In the top row, the outputs of the gates are seen. In the left corner, the power supply to the gates are here. We will see the circuit today app. As we seen before, the off adder circuit contains an XOR gate. Here is the symbol for XOR gate and the AND gate. Instead of using switches, we use a special component which is present at the bottom row and click here. Here the switchable source. We use this component instead of using the switches. But there are 2 inputs, so I select 2. This is the copy symbol and this is the paste. If we want to change the values or properties of any of the components, just click it, and by clicking the toolbar we are able to change the values of the components. Here we are copy and paste the components, so just click them and click the copy symbol and click paste. To connect wires between these switches and the components, use this wire symbol and select 2 points where to connect the components. If we want to delete any of the components or wires, just click them. When it turns into yellow and click the delete symbol, it will be disappear. So I select these 2 points to connect them. Also this. The XOR gate produces this sum bit and the AND gate produces the carry bit. To see the output, we use LEDs. The LEDs are present next to the diodes. Here is the LED. The anode is connected to the output of the gate and the cathode is connected to the ground. Ground symbol is present here. I have already made the circuit. Let's see the circuit. Here is the circuit for off adder. I have also connected 2 extra LEDs to view the input and 2 output LEDs. This is the circuit for off adder. In the switches, if we long press them, it turns into 0, and again we long press them, it turns into 1. The switches produces 2 values, one is logic 0 and one is logic 1. Here the cathode of the LEDs are connected to the ground and the output side also. Let's run this. I have already rotated this is for A input and this is for B input. This is carry and this is sum. Using the designation. Okay, let's verify the truth table. 1 and 0 means it produces sum as 1. 1 and 1 means it produces 1 0, which means carry is 1, sum is 0. Let's go for the full adder circuit. Full adder is nothing but a combination of two half adders. And full adder is a circuit which adds three inputs. In half adder we have seen that two inputs are added, but in case of a full adder it adds three inputs and produces two outputs. This is the circuit diagram for full adder. The full adder is implemented using two half adders. Here is the first half adder and here is the second half adder. Some of the connections may vary, and finally we are using an OR gate. We will implement this using this app. And one more thing, the truth table. The truth table of full adder contains three inputs A, B, and the additional input is C in, carry in. We will see what is the use of input carry in the upcoming videos. Let's construct this using the app. First we have to implement two half adders and reconnect them. I have already made the full adder circuit. Let's see. I have implemented the full adder using two half adders. This is the half adder 1, this is half adder 2, and the additional one OR gate is used. With the circuit diagram we all are able to implement this. Let's see, it's working. In the inputs here are three LEDs for three inputs A, B and carry in. Here it is the output carry and sum bit. Let's run. For A, B 1 1 it gives 1 0. What happens when all the three inputs are high? Let's see. A, B, C all are high. 1 on 1 means 10 plus 1 11. It gives output carry 1 and sum bit 1. With the truth table, using the truth table we can check the conditions. You may also implement and check the remaining conditions. So thank you friends.